Hello GATE aspirants. Welcome to part 11 of GATE Thermal and Statistical Physics series. Question number 16. As shown in figure, an ideal gas is confined to chamber A of an insulated container with vacuum in chamber B. When the plug in the wall separating the chambers A and B is removed, the gas fills both the chambers. Which one of the following statements is true? Option A, the temperature of the gas remains unchanged. Option B, internal energy of gas decreases. Option C, temperature of the gas decreases as it expands to fill the space in chamber B. Option D, internal energy of the gas increases as its atoms have more space to move around. Now this is an example of free expansion. And for free expansion, there is no heat exchange involved, so dq is equal to 0 and no work is done, so dw is 0. That means change in internal energy from first law of thermodynamics, it will be 0. So dt is also 0. So the temperature of the gas remains unchanged and there is no change in internal energy of the system. Next question. The internal energy U of the system is given by U is equal to lambda V raised to minus 2 by 3 S raised to 2. Where lambda is a constant of appropriate dimensions, V and S denote the volume and entropy respectively. Which one of the following gives the correct equation of state of the system? Now we know du is equal to Tds minus Pdv. So that means dou U by dou S at constant V is equal to T and dou U by dou V at constant S is equal to minus of P from this equation. So from here let us calculate T and P. So T is equal to dou U by dou S. So that is dou by dou S of lambda V raised to minus 2 by 3 S square. So that is 2 lambda V raised to minus 2 by 3 into S. So from here we can get S is equal to T upon this thing, that is 2 lambda, and this is V raised to 2 by 3. Next we have P is equal to minus of dou by dou V of U, and U is lambda V raised to minus 2 by 3 S square. So this will be lambda S square and derivative of this is minus 2 by 3. So this will be 2 by 3 into V raised to minus 2 by 3 minus 1. So that is minus 5 by 3. So this is P. So here we can substitute values of S here. So this will be P is equal to 2 by 3 into lambda into V raised to minus 5 by 3 into S square, means square of this. So this will be T square upon 2 square lambda square. So that is 4 lambda square and V raised to 4 by 3. Now all these are constants. So P is equal to, we have this constant 2 by 3 lambda upon 4 lambda square. This is a constant into we have T square into V raised to minus 5 by 3 plus 4 by 3. So that is V raised to minus 5 plus 4, that is minus 1 by 3. So V raised to minus 1 by 3. So that means we have P V raised to 1 by 3 upon T square is equal to some constant. So here option A is correct. Next question. For a gas of non-interacting particles, the probability that a particle has a speed v in the interval v plus dv, v to v plus dv is given by this equation. If E is the energy of a particle, then the maximum in the corresponding energy distribution in units E by kBt occurs at. So this Fv is given. Now we know energy is equal to half mv square. We will write this equation in terms of energy. So from here we can say V is equal to under root twice E by m. And from here dV is equal to root of 2 by m into derivative of root of E. So that is 1 upon 2 root E into dE. So dV is equal to 1 upon the root of twice me into dE. So this function will be now f of E dE. So f of E is equal to 4 pi V square is equal to 2E by m. So 2E by m into we have dv, but dv is equal to 1 upon under root twice me into de. Then we have this constant m upon 2 pi k kbt, whole thing raised to 3 by 2, and e raised to. We have minus mv square by e, so this will be minus of e by kt. So this is the expression that we are having. So this is equal to, these things are constant, 4 pi is constant, 2 by m and all these things are constant. So 4 pi into 2 by m upon under root twice m. So e upon root of e, so this will be e raised to 1 by 2. Then this thing is constant, e raised to minus e by kt, and we have constant m upon 2 pi kt raised to 3 by 2 into d. So here we have de as well. So from here Fe is equal to some constant k, this portion we are taking constant k, into we have e raised to 1 by 2 e raised to minus e by kt, and we want to find out its maximum value. So that means dFe by de is equal to 0 for maximum value of Fe. So d by de of e raised to half e raised to minus e by kt is equal to 0. So e raised to half e raised to minus e by kt into derivative of this, so that is minus 1 by kt plus e raised to minus e, the second term as it is, plus e raised to minus e by kt into derivative of this, so that is 1 upon, this is root of e, so that is 1 upon 2 root of e, and whole thing is equal to 0. Now this exponential term, it cannot be 0, so it is non-zero value, so we will get root of e upon kt is equal to 1 upon 2 root e. So from here e is equal to kt by 2. So in the units of kt it will be half. So here answer is 0.5, and answer in the answer key is 0.5 to 0.5. Next, the Planck energy density distribution is given by u of omega is equal to this. At long wavelengths, the energy density of photons in thermal equilibrium with a cavity at temperature T varies as T raised to alpha, where alpha is. Now, in the long wavelength region, long wavelength means low frequency region. This h cut into omega, this will be much smaller than kt. That means e raised to my h cut omega upon kt. This will be nearly equal to 1 plus h cut omega by kt. So we will use this. So from here e raised to h cut omega upon kt minus 1 will be nearly equal to h cut omega by kt. So this u of omega, this function, this will look like this, h cut omega cube upon we have pi square c cube, and here we can write h cut omega upon kt. So this h cut will cancel out and one omega will cancel out. So from here we get u of omega is equal to omega cube upon omega is omega square into we have kt upon pi square into c cube. So this is proportional to, so u of omega is proportional to t, so t to the power 1. So from here alpha is equal to 1, so alpha is 1, and answer in the answer key is 1 to 1. So these were all the questions from GATE 2020 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.